So so emergence again can also be understood in many senses, but broadly it is divided into epistemology, which is sometimes considered weak emergence, and another variety is ontological emergence, which is considered strong. There may be people who disagree with this, but yeah, I'm just taking a general view here. So epistemological emergence is basically, again, it's very complicated, but to catch the core of the idea of epistemological emergence, we can say that because we are fundamentally limited cognitive agents, because of our calculational or epistemic limitations, some properties or some things in the world can seem emergent to us. But it's not the actual case that they are emergent. It's just that they seem emergent to us because of our limitations. See, that's the core idea of epistemological emergence. But ontological emergence, on the other hand, posits that there are things in the world which are actually emergent. They are emergent not just because of our limitations. So that's how ontological emergence proceeds. And I will be concentrating more on ontological emergence for reasons that I'll try to explicate. So these are the slogans that capture emergence. Parts behave differently in wholes, and the whole is more than the sum of the parts. So yeah, these two are loaded slogans, and by the time I'm done with my presentation, yeah, I think we can get a clearer view of these two slogans. And like I said, there are many notions of emergence in philosophy of science. So there are many frameworks even to discuss these many notions of emergence. Several philosophy, there is like huge amount of literature dealing with just different frameworks to tackle the complexity of the notion of emergence. But I'm going to concentrate on just this one framework called the New Mechanist Framework, which I think is apt for this discussion of emergence and its conflict with reduction. So I'll explicate, or I'll try to explain why that is the case. So again, the first reason is this. This is the thesis of ontological reduction is about things posited by various sciences in the world, right? Things means, I mean all the things, like from electrons to stars, everything. So in order to and we argue and ontological reduction says that all those things can be reduced to the fundamental things. So in order to deal with such a claim, we need a framework that deals with the things posited in sciences and the scientific practice that encourages such positing, such positing. So the new mechanical philosophy is such a philosophy of science, such a movement in philosophy of science, we can call it, that actually grapples with this practice of positing things and whether those things exist or not. So here is a quotation from Stuart Glennan's book, The New Mechanical Philosophy. It is an attempt to say how things hang together. Here, the things are basically nature and science, understood in the broadest possible senses. So the New Mechanical Philosophy says of nature that most of the phenomena in nature depend on mechanisms. What are mechanisms? He says mechanisms are collections of entities or things whose activities and interactions suitably organized or responsible for these phenomena. So the chief business of science, according to the New Mechanist philosophy, is the construction of models and explanations that describe, predict, explain these mechanism-dependent phenomena. So this is the basic idea behind the New Mechanist philosophy. So it has its origins in several discrete attempts by various philosophers of science in the late 20th century, and it has been going on even now until there's so many papers written, books written on the New Mechanist philosophy. And these are some of the philosophers who are known to be New Mechanists: Stuart Glennan, Nancy Cartwright, William Ensad, James Woodward, Peter McCormack, Darden, Raver, Carl Gillett. So why the name New Mechanism? Why not just mechanism? It's because the name derives from the contrast with the old mechanist philosophers such as Descartes, Newton, Galileo that we all know. I mean, for them, when during the period of scientific revolution, they all thought that they could explain all the phenomena in the world by just understanding, breaking them down to their smallest constituents and understanding their properties and behavior. They can explain the whole world. That's what they thought, including the heavens. But for these old mechanists, the smallest constituents are like metaphysical entities, such as these corpuscles, like the smallest things. These metaphysical entities have some properties, some like philosophical properties, And if we understand them, then we can understand the whole phenomena, all phenomena in nature. So that's how these old mechanists proceeded in their philosophy about the world, understanding about the world. But the new mechanists kind of have this commitment, but those commitments and other commitments that these new mechanists have are more sophisticated. So I'll try to list these commitments here. So the first commitment is nature is hierarchically arranged, as in like there are many levels, like various levels in nature, and each level has its own set of things interacting together and leading to various phenomena in the world. So, and then, so when I say thing, I have been using the word thing since the beginning of this presentation. So what I mean by thing is that I intend it to be very metaphysically neutral in the sense that it can refer to anything in the world. I mean, if we look at it from the traditional perspective of ontology, it can accommodate any of the following categories: substance, process, relation, etc. But in the new mechanist ontology, we don't use the term substance anymore because it's not updated enough to capture the things or entities posited in science. So in the new mechanist ontology, the word thing is a general term that can accommodate entity, which can also be called individual or object, activity, which can also be called processes or interactions, and then property or capacity, powers, relations, etc. Even levels can be considered a thing in the new mechanist ontology. So that's why I'm saying that by thing, I refer to anything that science posits in the world. That's what I mean by thing. And it is, I hope that people agree that it's metaphysically neutral. Okay, so as we saw before, all the phenomena in the world are produced, maintained, or underlaid by mechanisms. For the old mechanists, as I said earlier, the mechanisms contain only microcorpuscles and their interactions. But for the new mechanists, mechanisms in various levels can involve various things, from a small thing such as ion molecule to a large thing such as stars, social groups, planets. All these can be part of mechanisms depending on which phenomena they try to explain or account for. So not only these entities or individuals, even processes are parts of mechanisms, such as transmission, attraction, repulsion, revolution, even social revolutions. They can be part of a social mechanism that results in social change. That can also be considered as a mechanism. And then properties such as charge, mass, voltage, even that is admissible in the new mechanist ontology. Powers are also admissible. So again, this is a general definition for a mechanism. A mechanism for a phenomenon consists of entities whose activities and interactions are organized so as to be responsible for the phenomenon. So yeah, this is like evident enough. We don't need to go deep into it. So if we want to look at examples, there are plenty of examples. Even mechanism of speaking, when I speak, like how do words come out? It's because of my vocal cords, how my vocal cord vibrates, how air goes into my lungs and comes out, how my stomach muscles contract and expand to produce the words that I want to produce. So all these work together, all these various parts in my body and various activities such as stretching and elongating, all these organize together to result in the phenomenon of speaking. So that's how we understand. But when we give an explanation for the phenomenon of speaking, this is how we would give a mechanism. It tells us what things in the world, which is what things in my body, which things in my body give rise to the mechanism of speaking, phenomenon of speaking. So in the same way, we can have a mechanism for internal combustion engines, propulsion engines, even the mechanism of the action potential in neurons. We can have mechanisms for all these various phenomena in various levels of the world. So again, traditionally, the world has been understood as static and undisturbed, in which various things exist, and philosophers try to understand. Scientists try to understand their interaction, their properties. But for the new mechanists, the world is understood a very different way. So this is something that I wrote myself. So I'll just read it out. The world is not a static thing. It is but a dynamic collection of phenomena whose existence is largely governed by mechanisms. These mechanisms can be simple things or complex things spanning across multiple levels of intricate organization, which can be further decomposed into less complex things such as entities, activities, properties, and powers, And these entities, activities, properties, and powers are always at work or have the potential to be at work because of the various horizontal and vertical relations that exist between them, thus giving rise to all the booming and buzzing phenomena that make up the world. So for the new mechanists, the world is not there, and then phenomena come into existence. All the phenomena that are already acting, that are already in development, that are already like dynamic, they're moving, they're in action. And those phenomena make up the world. The world doesn't exist independent of these phenomena. So yeah. So as I said, the new mechanist ontology permits levels in its structure of the world, which makes the world hierarchical. And then there are various relations, horizontal and vertical, even diagonal relations that exist between things in various levels of the world. So then even among these relations, there is causation, production, determination, etc. But these are all various relations. Even mechanists have so much literature on specifically on causation, specifically on production, determination, etc. For this discussion, I shall concentrate on just a vertical relation or the class of vertical relations that people or the mechanists usually associate with the phenomenon of emergence. So I understand emergence as a vertical relation between things in different levels, and I'll explicate why I think of emergence in that way. So in his book, Gillett, in his book Reduction and Emergence in Science and Philosophy, Gillett has developed a similar framework. He calls it the framework of scientific composition, where things in higher levels, which are composed of things in lower levels, if we try to explain the thing, I think in the higher level by providing it, by explicating how it is composed of things in the lower level, how the properties or the activities of the thing in the higher level results from the properties and activities of things in the lower level. That kind of explanation is a compositional explanation. So it's like it belongs to the same family of mechanistic explanation, and there are some contours that like pose some tension between compositional explanation and mechanistic explanation, but I think they both come under the same fold within the mechanistic framework. If we take the mechanistic framework as broad, so I take Gillett's work on reduction and emergence to be part of the new mechanist framework, and I would like to develop Gillett's work within the new mechanist framework. And Gillett and his fellow researcher Kenneth Aizawa, they also argue that they have a pluralist, they defend a pluralist account of compositional explanations, and there they relate mechanistic explanations and compositional explanations. So I take them to be part of the new mechanist framework. So now we'll see Gillett's account of emergence as a vertical relation. So again, like emergence is a very complicated, as in like it's not as complicated, but still like it's very abstract. In order to understand how it works, it's better to look at a case study or to look at from a particular case perspective. So I'll just first give an example of a phenomenon of the action potential. I argue that the membrane potential in the phenomenon of the action potential is an emergent property or emergent thing. For that, first I'll tell you, I'll give an account of what the action potential is. The action potentials or an action potential is the rise and fall of the membrane potential in the axonal member of a neuron. It's the rapid rise and fall of the membrane potential. That's what is called action potential, and it travels from one end of the axonal membrane to the other end. And it is this phenomenon of transmission of action potential that underlies neuronal communication, that underlies signals, how neurons send signals to each other, how neurons send signal to other muscle cells. So here I'll try to give a mechanistic explanation. It's already there, I'm just putting it out. The phenomenon starts first in the neuron. There is a neuronal body, and then there are dendritic trees, and then there is the axonal membrane, which is the tube-like structure that extends. So inside the membrane is a lipid bilayer, protein bilayer, and there are many channels embedded in that bilayer, in that layer of that axonal membrane. And then there are ions inside and outside. There are sodium, potassium ions, chloride ions, other proteins, anions. They are all there. So somehow the resting potential of the neuronal axonal membrane is minus 70 millivolt. So that's how they are organized based on the electrochemical gradient. So now the phenomenon starts when there is excitatory signal from neurotransmitters. When there is excitatory signal, what that means is that some channels some ligand-gated channels or chemical channels open when there is some excitatory signal. When they open, there is ion movements from inside to outside or outside to inside of the external membrane. So when there is ion movement, when positive ions enter, such as sodium ions, or when potassium ions go outside of the membrane, the potential starts increasing, the membrane potential. So when the increasing potential reaches the threshold value of minus 55 millivolt, this will lead to the opening of the sodium channels that are aligned alongside the wall of the membrane. Once it opens, what will happen is all the sodium ions will start pouring in. So these are positive ions. So the membrane potential will again keep increasing. So that is called depolarization. And the membrane potential reaches plus 30 millivolt, then the sodium channels slowly start closing, and they close immediately, and the potassium channels start opening. Once they start opening, all the potassium ions inside the membrane, they start pouring out. So again, the membrane potential starts dropping. So it even undershoots to minus 85 millivolt. And then there are leak channels and other sodium potassium pumps. They slowly bring the membrane potential back to the resting value of minus 70 millivolt. So this is how, then the termination ends. So I'll just give you, so this is the picture. This is how the membrane potential rises and falls. This is called the action potential. The sodium ions start pouring in, the membrane potential goes up. The potassium ions start flowing out, the membrane potential goes down. So then slowly it reaches the resting potential value. So in this picture, you can see these are our various channels. This gray channel is sodium because it has ball structure, and then the other one is potassium, and then the other one is leak channels, etc. So this is how an axonal membrane looks. This is what the axonal membrane looks like. So this you take one cross section, and there are thousands of channels in one small cross section. So there are like I don't know, millions of channels in one axonal membrane, I guess. So here's how the action potential proceeds from one end to the other. So sodium ions start coming in, the action potential rises to the peak, and then they enter the sodium ions that enter, they start moving towards right and left, which triggers the next membrane, which triggers the channels in the next membrane. Again, sodium ions start coming in the next section of the membrane. And then again, that triggers the sodium channels in the next section of the membrane. So this is how the membrane potential keeps rising to the peak from one end to the other. This is how signals propagate from one end of the external membrane to the other end of the external membrane. So in this mechanism that we have just seen, the axon, cell membrane, sodium, potassium channels, they're all examples of entities or individuals or objects. So this is what we call them in our new Mechanist framework. And the higher level entity or or individual is the axon, the neuron's axon, the whole tube-like structure. And it is constituted of cell membrane, all the channels, sodium potassium channels, the sodium potassium pumps, leak channels, etc. So this constitution is a compositional relation between individuals. And then the membrane potential is a property of the whole membrane. Then membrane current is also a property of the whole membrane. Charges and the electric fields are all properties of each ion inside and outside the membrane. And then sodium and potassium conductance, they're all properties of each channel, each voltage gated channel. So here, if we take the membrane potential, which is the property of the whole, it is realized by the lower level electric fields of all ions. See, membrane potential is measured with respect to 2 points. It can be measured with respect to 1 point, which is the amount of work done in moving one charge from 1 unit charge from infinity to that distance, or membrane potential between 2 points. Here in our case, membrane potential between outside and inside. That's how we measure it. So it's the amount of work done to move 1 unit charge from the outside to the inside. So in order to measure that, we need to take account of all the electric fields that are present within the vicinity where we are measuring the potential. So there we need to take into account all the charges, all the electric fields that radiate or go towards the charges in each ion, charges from each ion. So we can understand that membrane potential, which is higher level property, is realized by the lower level electric fields. Again, then if we take process of the action potential, it is realized by the graded potential, which is the signal, which comes under threshold. Before threshold is attained, it's called graded potential. And then process of depolarization is when the action potential goes up. Process of repolarization is when the action potential comes down. The hyperpolarization means overshoot. So the process of action potential is implemented by the process of opening and closing of channels and all these other lower level processes. So we can see how compositional explanation, comes under mechanistic explanation here. Then again, you can see the powers are also realized by the lower level powers, higher level power realized by lower level powers. So yeah. So now you can see how the higher level things are realized or are composed by the lower level things. So according to Gillett's account of emergence, it is ontological because he argues that it is out there in the world. Here emergence, he understands emergence as a downward non-causal determination of the components, which means the parts, which means the lower level things. The determination of the lower level things by the higher level composed thing. So he uses the word macrasis to characterize that relation. So that he says it comes from two Greek words, macro and crisis. So which is that, and that macratic relation is a non-productive relation because it doesn't result in any manifestation of new power. That is, for him, emergence does not consist in the manifestation of any new powers. What it only results in, it only means there is whatever powers are already there, they are manifested. And the non-compositional means if it goes from downward to upward, it is compositional because the lower level things compose the higher level things. But when the relation or the determination comes from upper level to the lower level, it is non-compositional. It is not compositional because there is no composition going on there. It is a different kind of relation. So yeah, and he says that it's productive role shaping because the higher level property or thing, it decides or it determines what powers can be contributed by the lower level things, which are already present in the lower level things. It will make sense if I look at the example. If we look at the example in the next slides. So yeah, according to scientific emergentists, the account of emergence given by Gillett, both higher and lower level things, they determine each other mutually. So that's why both upward and downward relation exists. So that's the same point. So when there is downward determination from the higher level to the lower level, it leads to an alteration in the powers contributed by the component things, the lower level things. So that's how we can make sense of emergence in this framework. The higher level thing exerts a downward macratic, non-compositional, non-productive, non-causal even determination on the lower level things, and that makes the lower level thing contribute differential powers. Yes. So the powers contributed by the lower level thing because of the determination from the higher level thing are called differential powers. And again, Gillett makes that macrasis is a unique species of determination. It's not compositional determination and it's not causal. Yeah, because composition is also not causal because it's the same thing. Composition, the lower level things realize the higher level thing, which is both the higher level thing and lower levels things are the same thing. I'll explain more on this later. So now again, in order to make sense of all these abstract accounts, we'll look at a case study first. So again, take the case of the action potential. Here as we saw earlier, the membrane potential V, which is at the higher level, it is the result of the electric fields from the lower level, as in from the electric fields that are associated with various ions inside and outside the membrane within that vicinity. So again, the higher level properties realized from the electric fields in the lower levels. This is a compositional relation. The realization is a compositional relation. And we also know that in the phenomenon of the action potential, when the membrane potential rises and falls, it happens only because the sodium and potassium ion channels open and close. If they don't open and close, there won't be any transmembrane ion flow. And if there is no transmembrane ion flow, there is no action potential at all. So these are the main reason for the occurrence of the action potential for the phenomenon of neural communication. So, but the thing is, the research is still going on how the ion channels open and close. I mean, how their structures change to let the passage of ions. It's still people are still trying to find out because it's in the lower molecular level. But we do know that the channels change their physical structure, their conformation, because of the voltage because of change in the membrane potential value. That has been established for sure in neuroscience. But the voltage is at a very higher level, right? We can only measure it with respect to the whole membrane. So if the channels open and close, it can only be done. I mean, it can happen only because of some kind of influence from things that are in close proximity, physical proximity with those channels, right? So then only the ions and the electric fields are in close proximity to these channels. Therefore, only they must possess the power to open and close these channels, these voltage-guided channels. But the thing is, without the higher level property, which is the membrane potential, the voltage value, such as the threshold value -55 or 70 or 85 millivolt or 30 plus 30 millivolts, without that value, without that property, the higher level property of membrane potential, the electric fields just won't contribute that power of, just won't exhibit the power of, manifest the power of opening and closing the ion channels, and the ion channels simply won't open and close. So that's why the powers possessed by the electric fields around these ions, these powers are differential powers, and because they manifest only as a result of the presence of the higher level property, the membrane potential. So that's why I argue, it's my conclusion, that the membrane potential has to be an emergent property, because without the emergent membrane potential, the lower electric fields cannot contribute that power, cannot contribute those powers and make the channels open and close. But it is not downward causation. One might think that this downward causation is not emergence. But the thing is, it's not downward causation for several reasons. I'll tell you why. But in fact, downward causation exists not between the membrane potential and the electric fields, but between membrane potential and the sodium and potassium conductances, the overall conductances that arise from all the channels. So Woodward in his papers, these two papers, downward causation and levels, and the other paper, argues that the membrane potential downward causes the sodium and potassium conductances. The sodium and potassium conductances GNA and GK are the overall membrane conductances to sodium and potassium ions, which is when we take a section of the membrane, GNA and GK refer to the whole conductance levels. So for him, this is the account of downward causation that he gives. This is the quotation. Like Woodward is an interventionist, so he understands causation within his interventionist framework. So there are I'm not going to read that. So there are based on his quotation, we can take there are 5 conditions that we can derive. If two things satisfy these 5 conditions, then they are in a downward causation relation. The thing is, first condition is they must be variables, which means he means that whatever in the world corresponds to variables. So what he means is that it has to have it has to have the capacity to vary its